Good morning, everybody. Welcome back to Data Programming 1. Today we have our third and final lecture on databases. And today what we're really going to be looking at, we're only going to learn one new technique. But what we're going to be learning is the connection between SQL and Pandas and how learning something in Pandas makes learning something about databases easier. Learning something about SQL will make learning how to do the same thing in Pandas easier. A couple of just announcement kind of things, reminders about the course. First, late days may not be used on the last project. Second, regrade requests need to be received within 1 week of the release date of the grades. In the last week, Mina and I have gotten 5 requests to make exceptions to that to regrade like very early projects in the semester. We just don't have the manpower to do that. I would love to help you guys out. It's important to me that you learn as much as possible, but if we said to everybody, go back, do anything you want again, and we'll grade it, we can't do it. So I've had to deny all of those requests. I apologize to those students that I can't help you, but we just do not have enough people to regrade everything. So that's why we have that policy. All right, next up, it's Thanksgiving week, so everybody have a great Thanksgiving. Heads up, our entire team is taking Thursday, Friday, Saturday, and Sunday off. We're not going to be answering emails. We're not going to be manning Piazza. There is no office hours. Just a heads up. All right. And today we have, let me pop over to the webpage real quick. One sec. All right, here we are. Week 13. Can you believe it's week 13 already? Databases 3. So let's see what we got here. First, all we're going to do today is go through a worksheet. This is going to be one of those, as much as I can make it a guided learning exercise. I'm going to have a problem. I want you guys to pause the video, try and do it. You know everything you need to do these with one new technique, and I'll bring that up when it comes. And in fact, that new technique is basically the SQL version of bucketize. Feel free to just write the bucketize function and go back and grab it from your homework and bring that in and do it using that technique. All right, anyway, the worksheet, we've got 2 different versions. The PDF version actually looks really clean. The Microsoft Word document, when I loaded it on Windows, the graphics are like overlaying the text a little bit, but apparently it looks really good on Mac. So apologize. If you're a Windows user, grab the PDF version. Mina beat me again. It is actually 2:30 in the morning as I'm recording this. I gotta admit, having the little guy here playing video games in the background is extremely distracting, and I just have trouble getting the recording of the quality that I want while he's playing games in the background. All right, and then in this code directory, one second, let me grab that. Here we are in the code directory. We have 3 files, 2 notebooks. The worksheet, this is going to be right here, this one. The list of those questions on the worksheet put into a high-tech, Jupyter notebook format. And this is the one I'm going to be going through and filling in. It lets us run the code, it lets us try things out, and we can format the questions so they look really good. I've also got all the answers here. I believe this is the answers from Mina's worksheet. I'm going to have more or less the same thing. It'll look very similar at the very end, but we're just going to leave Mina's answers up right here so you can see her version as well. And then you'll also need this database file. We're looking at SQL statements, reading, trying to extract data from a database, so you'll need that one also. All right, let's just go ahead and dive into this and get started. All right, and again, here's the worksheet. The best way to learn computer science is by doing. It is so much more efficient to actually do this yourself, to struggle with it, to get it wrong, and then come back and watch the video, see the answer, than it is to just watch a lecture. If you're sitting there with your phone and your roommate's playing Xbox, you're not going to get very much out of this. Go sit down at a real computer, pause the video at the right time, and try these on your own. So much more value out of doing that. All right, let me just give you a quick walkthrough. I'm going to scroll down to the first question, and then I'll come back to the top. More or less, all of these questions run the same way. There's 2 versions. It says, without running this cell, predict what this is going to do. Okay, this is a Pandas statement. And then it's going to say, convert that statement to an equivalent SQL query. And then the next one is the reverse of that. Here's a SQL query, predict what it does, and then convert it to a Pandas statement. All right, they're all kind of like that. All right, so let's rewind a second and take a look at the structure of this part. Okay, so the very first top cell is, again, the reformat the screen so that it all fits on the screen and looks good. This lets us get the red color in our questions. All right, and then we're going to be using databases. So we're going to be looking at SQL and Pandas. So we're going to import both of those. We're going to create a connection to the worksheet.db. That's in the directory. You'll have downloaded that. And then here in cell 4, we're going to be looking at, this is just a function query that's going to make it easier to focus on just the SQL statement. So we're going to give it the query. That's going to be the SQL statement. And it's going to take care of the fact that we're actually reading it through Pandas using the read SQL statement. And it needs that connection object. So from this point on, I can totally forget about all of that like little machinery behind the scenes stuff and just focus on writing the SQL statements. All right, sounds good, right? Okay, let me run those cells and then we'll come back and we'll start exploring what this data looks like. Give me a sec. All right, went ahead and did that. So the very first thing we should do anytime we're working with a database is to do the select star to get all of the data from SQLite Master. All right, and I went ahead and wrote this one out without using the query, but this could have easily been done using that query statement function. All right, what we see here is that this database actually has only 3 tables in it. These 3 tables are from the city of Madison. Madison keeps data about absolutely everything. The first one is about where all the fire hydrants are located, and I'll pull these up in just a second. What color they are, where they are, stuff like that. Database of all the trees that are maintained by Madison. And again, then another subtable about the species code of the trees. Hey, let's just take a look at these. Let's start with hydrants. So I'm going to copy and paste hydrants right here. We'll run that cell. We can see that this table only has 6 rows in it. Year installed, what color they are, what model they are, whether they're publicly or privately owned, a code to identify them, and whether they're currently in use or not. Okay, so it's just, obviously there are more than 6 fire hydrants in Madison. This is just enough data to give us some to work with, to answer questions about, and not be overwhelming and like fill up the entire worksheet with like lines and lines of output. All right, let's take a look at this trees data table. I'm on that cell. All right, here we go. So here we have some encodings a little bit. We've got 5 trees in this database. So again, it's just a subset. Madison has lots of trees that are maintained by the city. We've got the index, because this is when I do a query like this to select everything from trees, it's going to return a pandas data frame. So these are the indexes. I've got names for the trees, and I've only got 6 trees here. Whoops, 5 trees. So I'm just giving them letters to shorten this up a little bit. We've got X and Y coordinates. And again, this is in city blocks based from some center point. What species they are, and this is just a code that's identified in the species table. How big they are, and again, some trees are more important to Madison than other trees. They might be in key locations, or they might just be really old trees or of historic value for some reason. And so they have a priority about maintaining them, whether they need trimming more often, or perhaps they're in the way of power lines, or whether they're important to be maintained for whatever reason. All right, next up, the species is a very simple table. All it has is the species code. And again, this is a data frame, so it's giving us the indexes. But the species code and what species that corresponds to. So M is going to be a maple tree, and P is going to stand for a pine tree. All right, guys, at this point, I'm going to start going through problem 1 here. I'm going to encourage you to just pause the video, give this a try on your own. If you get it, if it all makes sense to you, you can always go back and check your work. You can just delete that, run this cell, see what you get, and see if it matches your prediction. But I highly encourage you guys to just take some space, write down what you think this will produce. You'll learn more and you can check your work. And then if you'd like to, you can come back, watch the video, and I'm going to go through this step by step, break it down, and try and bring in a lot of review ideas and bring in some more general concepts to explain what's going on here. All right, so I'm going to start going through this right now. Pause the video, give it a try, and then come right back. Okay, now when I look at this statement, I can see I'm working with the trees table. Let me go ahead and pull trees back up. So we've got it right here to refer to. There we go. And then the next thing I see is a whole lot of brackets. Now my goal here is to explain what's going on and make this as educational as possible. So I made some PowerPoint slides. I'm going to jump over to those and get this color coded so I can talk about which bracket does which thing, because they all mean more or less something different. All right, here we go. So I copied the statement. I've got my data table, and then I've got the pandas command here. So first thing, when you read statements with lots of brackets like this, we'll go ahead and read them left to right. And then for each pair of brackets, so here's the first bracket I come to, this blue one, it closes right there. So I'm going to take a look at this chunk first. And then I've got a purple one, closing purple one there. I'm going to read that second. Now, when I read inside of a pair of brackets like this, I'm going to actually read them inside out. So the very first thing I'm going to look at is red, then blue, and then green, then purple. So that's the order I'm going to take a look at these things in. Very important, left to right, inside out. All right, so if I start with the very most inside one, this red one, this is trees, followed by brackets. So that means I'm going to be using these brackets to access something from trees. I'm extracting data from the tree data frame. Okay, and what I'm extracting here, when there's no .ILOC or just LOC, if I just give it the straight up brackets, it's going to be looking at a column. And in fact, I've got a really big clue right here because what I'm accessing is the priority column, and there's only one word priority right here. So let me click. This is going to give me a series. I'm getting just the column out. So here I have my indices copied from right there. And I've got all of the data from that column, 71, 100, and so on. All right, so the next thing I'm going to do here is figure out, look at everything inside the blue statement. So this part gives me a series, and now I'm going to use the greater than operator. Is this greater than 90? And this is going to give me an element-wise comparison to 90, and return true or false, one row at a time, based on whether the number is bigger than 90. So it's giving me a Boolean series back. Let me just go ahead and, yep, I'm doing this much. I made these slides a year ago, and I'm trying to remember what comes next, so I'm a little slow on the clicking. This is going to give me a Boolean series. So let's see here. The first point was 71. That is less than 90, so it's false. 100 is greater than 90, so that one's going to be true. 30, 40 are false. 99, greater than 90 is true. Okay, so this much right here is giving me a Boolean series, and I'm using that inside the blue brackets to access trees again. Now this trees is again going to be the very full data frame, all the rows, all the columns, and what this is going to do is just extract some of the rows. So if I click through, I find out that the rows that have a true in them, that would be row 1 and row 4, are retained, and the others are removed. So this is selecting rows. Okay, so once I've got all of this blue stuff completed, I've selected some rows. I'm going to go ahead and take a look at the right half. So the purple one means that I'm going to be accessing stuff, because I'm using brackets following a data frame. This much right here in blue is a data frame. I'm going to be accessing data from this resulting data frame. All right, and what I'm going to be using, in fact, is a list. So these green brackets are creating a list. So the red one here was accessing something from trees. The blue one was accessing data with a Boolean series, also from the original trees. This means I'm accessing, the purple one means I'm accessing data from that resulting data table after I'd selected rows. The green is completely different. Green is creating a list. We learned how to do this week 5 of the semester, so like 8 weeks ago. We're just creating a list. When we access a data frame with a list, that's kind of the fancy slicing that Pandas lets us do. It's going to be selecting the columns X and Y. Oh yeah, and we can see that if we do type of this inside, the green brackets, it does in fact return list. Okay, so I'm accessing from a data frame using a list, fancy slicing, and that's going to just extract rows X and Y from, let me go back a second, from this table. So I'll still retain the indices 1 and 4, and I'll get just the columns X and Y. And there they are. So that should be my final answer. Just a quick reminder, I'm also going to have integer positions for these. So this first row here will be at integer position 0, and the row here with index 4, those are retained, is going to be at integer position 1. All right, this may be overkill at this point, but as you're walking through these things, I kind of want to give you the idea of what you might be typing in as you do the work for this problem. So I obviously just did it in PowerPoint. You have the answer. But if I were approaching this problem like on an exam, I'd have a sheet of paper out and take a look at this. So trees of priority is the very first thing I want to take a look at. And so that's going to extract this column right here from the data. So I'll be getting 71, whoops, hold on. Mike, you're messing it up. 71, 100, 30, 40, and 99. All right, I'm going to go ahead and put in the indices too so that I remember where I'm at. Okay, when I start deleting rows. All right, the very next thing I'm going to do is ask whether these rows are greater than 90 or not. So 71 is not. That's going to give me false. 100 is true. False. False. And 99 is greater than true. And this is creating a Boolean series. Again, these relational operators are all done element-wise, so one number at a time. Once I have this Boolean series, that's the result of this much, everything inside those brackets. I'm going to be using the Boolean series to extract rows from the data frame trees. So again, this is accessing a column. This is accessing rows. So again, two pairs of brackets used in different ways. So basically, I'm going to just go ahead and delete all of the rows with falses in them. Make this look good. All right, there we go. And when I do that, what I am going to retain is the entire row. So this is going to not just be true, but I'm going to have row 1. It's going to have B, 24, M, 10, and 100. And row 4, that's E, 50, 4, M, 12, 99. I'm going to pause for a second, put in my heading, and space this out so it looks good. One sec. All right, there we go. Hope that looks good. It's easy to read. So that's the result of this much stuff, the entire left half. The next thing I'm going to be doing is taking this data frame, this whole thing is a data frame, and accessing part of that data. And the part I'm going to be accessing is the list, so fancy slicing, that just retains the X and Y columns. So here's what it looks like. I no longer care about tree. Get rid of those. Slide that back over. I no longer care about species, diameter, priority. I'm not selecting those, so I can get rid of all of those. And this is what my resulting answer is going to look like. I'll just have the X and Y columns for those rows. All right, let me go ahead comment this. That's right. In Notebook, it's Control/ to comment. Messed that up a second ago. Okay, and then if I run this cell, this is the answer I get. Indices 1 and 4, and X and Y columns. All right, I'm going to go ahead and put this back. And again, Control/ to uncomment. There we go. All right, next up, I'm going to pause and get a timestamp, and then go ahead and do the very next statement, part 1B. All right, so 1B, we're going to convert this statement right up here from problem 1A into the equivalent SQL query. So I'm going to click on it. It's in blue command mode. I'm going to push B to get another cell below it. Put this one in code mode so I can type here. All right, I'm going to be writing a SQL query. So I'm going to use my query function. This function just takes one string. So there we go, a string. And I need, it's going to be a SQL command. So I need certain keywords. There are two that are absolutely mandatory. First one is select. Second one is from. Always need those guys. And they come in a certain order. They must be in the right order. So select will come first, followed by from. From is the easy one. I need the name of the table. Trees, or was it singular? I'm going to go back up and take a look. It's right here, trees. It is plural. Okay, so that's the table I want from the database. And what I want to do is select which columns I want. And here I want columns X and Y. There we go. I also want to restrict this to just certain rows. And so to restrict something to rows, that's the keyword where. And the rows that I want are rows where the priority is greater than 90. So priority greater than 90. All right, next up, I'm just going to run this and make sure that I actually have the right answer. Okay, it selected the right columns, It selected the correct rows. I've got 24, 54. However, it has renumbered them. When it created the new data frame from the SQL command, it created the data and then put it into a brand new data frame. And so the indices got renumbered. I'm not going to go ahead and talk about how to manually renumber the things within a SQL query. I'm going to just move on. That's beyond what we're doing in this course. I'm just going to accept this as the correct answer for this question. SQL is so much easier than Pandas. I love it. SQL is my favorite. I would choose this over Pandas given the choice any day of the week. Yeah, it took me like what, maybe 20 seconds to go through, type this, and explain it. It made sense. It's easy. These words are very clear compared to this stuff and that stuff. All right, but I think understanding Pandas makes it easy to translate into SQL, and the other way around too. So let's go ahead and do an example the other way around next. Let me pause the video, grab a timestamp so I can put it in the description. One sec. All right, number 2A. Go ahead. I got my timestamp. Pause the video yourself. Go ahead and give this a try. Predict what the table is going to look like. Then come back, check your work, and then watch the video for the in-depth explanation with like bonus material. Okay, so I can see this is a SQL query. The two mandatory pieces, select and from, are right there. And I should note that in my other examples, I've been putting each of these on their own line. I think that's, it makes it really clear to see, but there's no reason we can't just put everything all in one line like this. Okay, so the important part, start with trees. That's the table we're extracting. I'm just going to go ahead and grab that so I can refer to it while I'm going ahead and thinking about this. All right, I'm going to be selecting, actually I'm creating a new column. This is an aggregate column made by summing the X column and the Y column. And I'm also going to be limiting myself to certain rows, just the rows where species is equal to M. So I'm going to be grabbing, in this case, tree A, tree B, and tree E. So let me go ahead and write this out. All right, let's see. So this one, tree M, or tree A with species M, 10 plus 4 is 14. And then B is also a maple, so 20 plus 4 is 24. And tree E at index 4, also maple, so that's 50 plus 4 is 54. All right, when I draw out this table, the SQL version is going to be creating a brand new data frame with this data, and it's going to re-index everything. So I'll get index 0, index 1, and index 2. If I do the same thing in Pandas, it's going to retain the 0, 1, and 4 in the end. Again, we're not going to go into how to make that change in this course. It's beyond what we're going to do. All right, let me go ahead, comment this out. Let's see, Control/, don't screw it up. I don't need the trees for my answer. And I'm going to go ahead and run the cell and just make sure that that's what I'm really getting. Yep, okay, 14, 24, 54. It's re-indexed them, so 0, 1, and 2. This is looking good to me. All right, so I'm going to pause, get a new timestamp, and go ahead and check out question 2B. All right, all set. So question 2B is going to be converting this SQL query that we just did into Pandas. All right, this is hard, guys. Go ahead, pause the video, give this a try on your own. Good luck. And then I highly recommend coming back and watching this section of the video anyway, because I'm going to jump over into PowerPoint and walk through which parts, like here I've got a select, I've got a from, I've got a where, how I can take each of these pieces of a SQL statement and how that corresponds to the bracket notation in Pandas. Here, let me jump to PowerPoint real quick. All right, here we are. So as I was going through this statement from problem 1, I've already completed this one. I talked about it in depth. I thought this would be a great example. This left half, the entire part of this was grabbing just one of the columns, doing an element-wise comparison to get a Boolean series, and then selecting rows. Okay, now the selection of rows, it corresponds to the where statement in SQL. All right, so I'm going to be doing the same thing in problem 2B, where I'm going to be extracting some rows. And those are just the rows where the tree was equal to species M. And then the second part of that is I need to select some of the columns. And to select columns, we were accessing that new data frame and giving it the columns that I wanted to extract. Here I extracted the column priority. Here I'm extracting the columns X and Y with the list notation, sort of advanced slicing. So this is sort of the structure we're going to be working with. I've got where first inside the brackets with a Boolean series. Okay, both of those things need to be there. And then I'm selecting columns for the select part of thing. And the from is the trees part over here, which table I'm looking at. Okay, so let me jump back over to Jupyter Notebook. Here we go. Go ahead and convert this into Pandas. All right, B for a new cell below. Click there to get back to code mode. All right, here we go. First, I'm going to do the where part of this. So I'm going to be, well, here, let's just take a look at the table. There we go. All right, I want to select just the rows where trees are equal to M. So I'm going to go ahead and grab just that column. That's going to be column species. Let me go ahead and run this. There we go. Now I've got just the column. I need to turn this into a Boolean series, element-wise, bunch of true and false statements, so I can use that to extract the columns. So I'm going to say if that's equal to M, then I want to retain it. Let's try that again with the double equal. There we go. Oh dear. I just went ahead and changed on my data. Timeout. Let me rerun this from the beginning. All right. So I closed the connection. I went back up. I reopened it. After some thought, I didn't need to do that. All I needed to do was reread the trees by querying select star from trees. That's all I needed to do to reload that table. Now when I run this again, there we go. The first statement was just the equal. That's the assignment operator. I was rewriting the data in the table. That is not what I wanted to do. Okay, so now the equal, that's going to give me Boolean statement and test for equivalence. And there we go. So the data, let me just, where do I have the table? There it is. Yeah, row 0, 1, and 4 should be true. 2 and 3 should be false. There it is. 0, 1, and 4. 2 and 3 are false. Okay, so once I have this, I've got my Boolean series. I'm going to use this to access the data access from column trees, from table trees, access these rows. All right, so I add trees, I added some brackets. When I run this, I'm now extracting rows 0, 1, and 4. All right, this is looking good to me. All right, once I have this much, like everything I've written so far, is a brand new data frame. What I want to do is grab 2 columns from this. So one at a time. First, I'm going to get column X. And to do that, that's really simple. All I need to do is add more brackets and tell it I want column X. And the default, the version that Pandas writers decided was that if I just give it brackets and don't put in location or iLocation, is going to give me a column. So let's go ahead and run that. You can see I get the 10, 20, 50. That is that column. Perfect. That's exactly what I want. All right. Now I also need column Y. This was asking for X plus Y. So, to do that, I basically need to copy everything I've got here to get that second column, and I'm going to add to it. This addition is going to be element-wise addition. So I'm going to be taking the 10 plus the, I guess it had a 4 in the table. Yep, 10 plus 4, and then 20 plus 4, and 50 plus 4. Where was I? All right, I'm bouncing all around. And one more little detail. I don't want column X. I want column Y right here. All right, let me run this. There we go. So 14, 24, 54. All right, and again, there is one difference. This has retained the indices because Pandas never created a brand new data frame. And we also didn't retain the, SQL actually created a brand new header for this column because that's what select will do for us. It's going to redo the columns. The formatting of data frames, I talked about a little bit when we were creating them. I'm not going to do more here. I think extracting the data is the important part of what I want to get out of this exercise. So we'll save that for the future. All right, guys. Problem 3a. Again, this is predict the output of a Pandas statement. And I've got, this is complicated. This is a hard one. And again, the Pandas ones are generally much more difficult than the SQL statements. So go ahead, pause the video, give this a try on your own. When you get stumped, come back for a hint, and then after that, try again, and then I'll walk through this. All right, so go give this a try. And if you're ready for your hint, here's the hint. I'm going to break this down into, there's actually 5 parts of this. So the first part, I'm going to be storing the result in variable CD. Here's the first piece of that. Then here's this, oops, don't move it. Just, there we go. Here's the second piece of that. But not quite that much. That much is the second piece. And this one, I see the double equals right there. That's going to give me a Boolean series. Here's the third piece. We're going to be extracting some data from the results of whatever that is. The fourth piece right here is going to be the inside of the leftmost bracket. Again, we're getting a Boolean series out of that. And then the fifth piece, we'll be extracting something from that result. All right, so there's your hint. Got 5 sections. See if you can figure out some of those, maybe not all of them, and then come back for the explanation. In 3, 2, 1. Okay, so first up, I'm going to go ahead and pull up the species table and just go ahead and run that. So I've got something to look at. So this is the very first part of this. Again, I'm going to do these left to right, and then inside to outside when I've got like nested brackets. Okay, so the first thing, I'm going to be extracting something from the species table, and this is going to be the code column. All right, so what this is going to look like is I'm going to have a new series, so with rows 0 and 1, the code is going to be M and P. All right, so that's this much right here. Okay, so I've got a series now, a Pandas series. From that, I'm going to be using brackets to extract something from that. Okay, that extraction, I'm going to take a look at the inside now. I see the double equals. This is going to give me a Boolean series, so I'm going to be extracting rows. And the rows that I'm going to extract, here I'm going to take a look at species maple. So again, we're going inside outside first. But the species is going to be, let me go ahead and just write it over here a little bit because they're in the same rows. I'll have maple and pine. And what I'm going to do is create a Boolean series by asking if these are actually equal to the word maple. So this one will be true. I accidentally pushed control equal. Enter, so it ran that with all the garbage in there. And this one will be false. All right. Now when I use that to access that original table, just the 0M1P, it's just going to retain the row 0. All right. From there, I also don't need that. This is all that's left at this point. And from this much, or this series, I'm going to be grabbing the data at integer position 0. So that's going to be row 0 here. The data is just the letter M. So I'm getting just the letter M. And then I'm storing that in the variable CD. All right, let me go ahead. I'm done with this. I'm going to go ahead and just keep those here for reference. Control/ to comment that. I'm going to run and make sure that I've got this correct and didn't make any dumb mistakes. I'm going to run it. Oh, I need to print out CD. There we go. CD now stores the character M. So perfect. This is looking good to me. All right, now part 2. Let's take a look at this. Again, I'm going to read this left to right, and then, whoops, the outside brackets go to there. Left to right, this one first, then that one. And when I look at this one first, I'm going to go from inside to outside. So the inside most one is, it's got a double equal. This is giving me a Boolean series. Oops, I didn't quite get all of it. There we go. Double equal, give me a Boolean series. All right, the left side of this, I need trees of species. So again, I'm going to go ahead and just bring up my trees statement, or trees data frame, so I can take a look at this. And this is going to extract the column species from this. So when I do that, I'm going to get M, M, P, P, and M. Okay, so that's this much. And now I'm going to ask them if they're equal to CD. And CD is just the letter M. So here, this one is M. That'll be true. Also M, true. False, false, and true. Okay, one more little detail. I'm going to go ahead and add in the 0, 1, 2, 3, and 4 to keep track of which rows things are. So these are pandas, so those will be retained. So that's this much right here. That's giving me the Boolean series. And now from trees, I'm going to retain only the rows where this is true. So here, let me just go ahead and copy the entire row from the data frame. I keep this one, that one's true. I keep row 1, that one is true. And I keep row 4, that one is true also. And these guys are not retained, we'll get rid of them. Okay, so all of this stuff over here, the entire left half, gives me a new data frame with those pieces of data. All right, the next thing I'm going to do is extract one of the columns from that, and what I want is the tree column. So that's going to be the one that contains A, B, and E. I didn't copy the header, but that's the tree column. So I no longer will keep any of the rest of that data to the right, the X, Y, species, diameter, and priority. And I'm going to go ahead and make this look a little, get rid of the arrows. I don't think they show up very well. They're kind of light gray. So this is what I'm expecting. So let me go ahead and comment this much out and put this back in and see how close I am. All right, check that out. No mistakes. A, B, and E, exactly like I predicted, and it retained those indices. All right, part 3B, convert the statements into SQL. There's a couple little tricks you guys are going to need to be aware of as you tackle this one. The first little trick is that when we use SQL statements, they're always going to be giving us back data frames. And so we will need to do some pandas tricks to extract like just the character M. So it's going to be a data frame. We'll go ahead and use the data access functions from pandas to grab the letter M. And the other little trick that we're going to need is that it's expecting a character right here for this variable CD. So it'll need to be in quotes. So I'll show you how I tackle that. You've got choices. There's more than one way to do it. I'm going to tell you guys to pause the video, give this a try, see how far you can get, and then come back and watch the solution. All right, will you guys do that? I'm going to go grab a Mountain Dew and be right back. And that probably only took 1 second with the magic of video editing, but I'm back. I'm going to copy these lines and just make some room for them down here so I have a new copy. All right, so this is what I'm going to try and do. And I'm going to do it in 2 steps again, just like we did here so that it matches. I'm going to be creating a SQL query, so I'm going to use my query function. And again, this is going to give me a data frame back. And so I'll need to extract, we'll go ahead and do this, the piece of the data frame, just that letter M. Okay, when I take a look at this, first, before we get this far, I'm going to go ahead and pull up species. We're extracting stuff, and I want to be able to take a look at it. All right, so what we want is the, what do we want? We want to, here, every time we do a query, we need select from, and we're going to be extracting one of the rows. Okay, the table is easy. We want to extract from species. We'll be selecting the row code, the column code. So let's go ahead and put that in right here. And what we're extracting, the where here is going to be if species column is equal to maple, where species equals maple. All right, let's go ahead and let me take these back off and just check my work. So far, all right, this is what we got. All right, and again, I'm going to get some errors here. I'm just going to go ahead and put in species equals, 20 quotes. There we go, okay. Put in all the error messages that I get, all the common mistakes. Let me go ahead and put this back so I can talk about what I went wrong. Execution failed on SQL, no such column maple. And again, it's expecting text here in my query, so I needed to go ahead and put the maple in quotes because that's going to be an element of column species, and it needs that for the comparison. So that was the mistake I made. Let me see if there, yeah, no such column maple, following exception. Let me see if there's like a clue that would give me the idea that it was read query. Oh, here it is. Quote right there. That might be my clue that I needed. Oh, nope, that's just the quote because it's copying this code. I was hoping there'd be like a clue that I forgot to put it in quotes in that error message. I don't see one though. All right. But anyway, so that's a common mistake. I make it all the time. All right. So the next thing I need to do, here's my query. Let me put that back. I need to extract. So the second part of this is just position 0 of this. This is a data frame. So what I need to do is turn it into a series first. So I'm going to extract out the code column. And again, I'll need to put that in quotes to get me just the column. So that'll become a series at this point. And then I want position 0. And that will give me just the character M. So here's part of the trick right here. This much gets me a data frame. Okay, this much turns it into a series. So I can extract just the data at position 0. All right, so there we go. I'm going to store this in CD. And then we'll print out CD, just make sure it's still working, looking good. All right, so for the second part of this, I'm going to be extracting stuff from trees. Let me go ahead and pull up the trees table so we have something to look at right there. All right, and what I'm going to be extracting is the names of the trees that have this letter code right there. Oops, I got it all copied right here. This letter code right here. So just the name, the column tree. So that's my select. Here's my where. All right, so anyway, this is going to be a query. Query, I'm going to use this function. We'll go ahead and give it, and we always need select. We need from, we need where. And inside select here will be, well here, let's do from. We're grabbing stuff from trees. We are selecting the column tree, so that'll be the names of trees. And the where, this is a little tricky. What I want is where species equals, and in this case I'm going to go ahead and just throw in quote M. This is what I want. And again, I'm going to be going back and putting in the CD here to make it exactly match. But if I put in just quote M right there, I get the right answer. Again, it's going to renumber these because I'm creating a brand new data frame. Pandas will retain those indices, but I'm going to ignore that. Call this good enough for this lecture. All right, now the trick is I can't just put in CD right here. It's going to give me an error saying there's no such, no such column CD. What I really need is the name of that column. All right, species is the name of the column, but I need to get the text in here for CD. Now, a couple of tricks I can do. I need quotes around it, and I'm going to use my personal favorite is the format function. And then, because this is all a string from here up to here, it's a string function. I can call the method format on it and give it the variable to be inserted in between those brackets right there. So, in fact, let me just copy and paste this much of it. We'll comment this out briefly. We'll go ahead and run this, and this should return a string with a bunch of extra new lines in there, but it actually has this character inside of the quotes. That's exactly what I need. The temptation is to do this. Here, let me get rid of that. Let me put my comments away. And again, the temptation is to do something like, here we'll end the quotes, and then we'll put in plus CD. And then we'll get rid of that. So this much will be a string from here to here. And then I can just, concatenate using string concatenation CD. The problem with that is it's the equivalent of putting in the letter M without the quotes. I do have some choices. I could put a single quote right here. Just one of them though. And then I could concatenate another single quote right there. So this is another way to do this. That's going to give me the right answer. And again, with the string format, this is my preferred method. I love this. I'm just going to give it those single quotes with the character in the middle. It's a string function. We did this in week 4 of the class. CD, and then get rid of the rest of that. And that parenthesis will end my query function. So There we go. Yeah, this is a hard one. It's confusing because of that extra little string part right there. Good review of format. And the other part that's confusing and tricky, it's not just straight up. SQL queries give us a data frame. To get that just character M out like we had from the Pandas version, I need to actually do some Pandas data extraction on the data frame. All right, let's go ahead and move on. All right, guys, question 4a. Go ahead. It's another SQL one. This one's not too bad. Go ahead, pause the video, give this one a try on your own, and I'm going to go ahead and walk through my solution in 3, 2, 1, start. Okay, so here's the deal. We're going to be, let me go ahead and just break this down a little more. Selecting species from trees, ordered by priority descending. Let me just make this look like my other statements. All right, so this is what we're going to be doing in the end. Here's the deal. Let's go ahead and pull up trees so we have something to look at, and let's put this back as comments. So I'm just looking at trees and not getting error messages. All right, so I can see I'm selecting the column species, so MMPPM, but I'm going to be ordering by priority. So 71, I need to sort by this one descending. So I'm going to go ahead and put together the sorted version of the table. So I'm going to get 100 first, and then the species is M. So I'm copying a little more information than I would normally get if I were just extracting something. So 99 is also M, 71 is an M, then 40 is a P, and 30 is a P also. So there we go, ordered by descending, but I'm only selecting species, so I don't actually want these columns right here. So I'm going to go ahead and delete the priority now that I've got it sorted, and I'm just going to go ahead and, just delete these. And again, because it's producing a data frame, it's going to go ahead and number these columns, and it's creating a new data frame, so we'll be getting renumbered columns beginning at 0. So it's going to look something. Wait, I made a mistake. I'm selecting species. Let me go ahead and put that word in right there. There we go. Get something that looks like this. All right, let's check my work. Let's put this back and go ahead and run it. So there we go. 0, 1, 2, 3, 4, MMPP. All right, a little tangent. Looks like Madison is prioritizing their maple trees over their pine trees. To me, this really isn't all that surprising. Pine trees grow so much faster than maple trees do that if something happens, if it gets a disease or something, it's easier to just chop it down and plant a new one. Within a couple of years, it'll be back to full size. Maple trees, on the other hand, grow very slowly, and to replace one takes a lot longer. So I can see where they might prioritize keeping those guys alive. All right, next up, converting that query to pandas. All right, so in 4b, we're going to be converting that query code to pandas. This particular question isn't that challenging compared to the ones I just did. I'm going to go ahead and copy and paste this right here. Whoops. There we go. Here, so we have something to look at, and we'll comment that out. The trick here, we're sorting things. All right, I don't recall talking about sorting pandas data frames during that lecture, so let me just go ahead and walk through how to get extra information about pandas. And here's all I'm going to search for is sort pandas data frame. See what my choices are. Data frame.sort values. That looks promising. And this is in fact what we need. I'm going to be giving it a data frame. This is a method, so I'm using the dot notation. The method is called sort values. And then I've got all kinds of different things I can put in here to help tell it how I want things sorted. I need to give it a by, so this is going to be which column I need to sort by. That's mandatory. And then the rest of these things have default values. The thing that I'm going to need is the keyword ascending equals false in this case because we want to sort in descending order. All right, and then we've got all kinds of other like little tricks. How do we actually do the sort? What kind of sorting method do I want? Whether we want to do it in place or use extra memory. I'm not going to go into any of those. Let me jump back over to the to the Jupyter Notebook. All right, so at this point, go ahead, pull that up on your own, pause the video, give this one a try, and then I'll be right back to do my solution of this. All right, so we're going to be extracting some data from a pandas data frame. So here's the idea. The table we're looking at is trees. Let's go ahead and pull that up. We need to sort this. order by priority. So the keyword, that function or method was sort values. And I need to give that which column I'm going to be sorting by. So we'll go ahead and do priority. When I run it now, I can see that it is sorting in ascending order. All right, and I looked up the help there. The keyword I need, ascending. Default value was true. To switch the order, I need to give it the new value false. There we go. Now I've sorted the data frame in the reverse order, highest to lowest. And now I don't want the entire data frame. I just want I'm selecting species. So what I'm going to do is extract the column. To do that, we give it square brackets and tell it we want the species column. Let's go ahead and run that cell. There we go, MMMPP. And again, it's going to retain the keys. It's not actually creating a new data frame like the query SQL does. But I'm not going to worry about that for this worksheet. All right, so this one is much simpler. Let's go ahead and do the next one. All right, starting problem 5A now. Okay, here we're looking at another query problem. I like these. SQL is easier than Pandas in my opinion. All right, so here's the deal. We're selecting tree and priority, so 2 columns from the data table trees. I'm going to start with that. So there we go. That's what my data table looks like. I'll be selecting the tree column, the ABCD, and priority, 71, 100. All right, but the trick here is that we'll be ordering them by priority in descending order, and we're going to limit that to just 1 row. So as I go through this, let me go ahead and order by priority. So we'll get this row first, then the next one will be this one. Whoops, that's way too much, way too much. That one. And I could put the rest of these in. In fact, you guys can do that if you'd like. But we're limiting to just 1 row. And so we'll be keeping that top row right there. And we're only going to be keeping 2 columns from this. We'll be selecting tree and priority. So let me go ahead and say this first one right here, whoops, B is trees. And then we'll get rid of all of this stuff. And we have priority. Okay, at this point, this is going to be index 0. All right, just like that, because the query is going to re-index everything when it creates it. So that is this much right here. It's that query. All right, the next thing we're going to do is turn this into a list. So when I do this query, it's getting a data frame. All right, hold on. Whoa, slow down a second. I tricked myself and didn't highlight the right brackets. So this much is inside of the list creation. All right, so let me rewind a second. This much creates a brand new data frame using the SQL query. From that data frame, I'm going to be grabbing row. So this is integer position 0. The row at integer position 0. There is only 1 row. That's this row right here. Now, that's going to create a Pandas series, and because Pandas series are iterable, I can put them in the list constructor and generate a list from this. So at the end of the day, I'm going to be getting character B and the number 100 in my in my Python list. Okay, let me go ahead and just double check this. I'm going to go ahead and comment that. Go ahead and uncomment this one and run the cell. And indeed, we get a Pandas list with character B and the number 100. All right, guys, converting this statement into Pandas is also pretty straightforward. Go ahead, give this a try. Remember, we'll need to sort using the function is called sort values. I'll scroll up right here. It looked like that. We'll need that again. All right, go ahead, pause the video, give this a try. And answer incoming in 3, 2, 1, go. All right, first up, I'm going to be extracting data from the tree table. So let me go ahead and just take a look at trees. There we go, got that. Now, I also want to sort this order by priority. So the command for that is sort values, and that requires at least one thing. Priority is mandatory. I need to tell it which column I want to sort by. When I run this code, it's going to sort in ascending order by default. So we want to go ahead and reverse that. Keyword ascending equals false. Now that should reverse the order. All right, so then I want to limit 1. The command to do that is exactly the same as we used up here. In fact, this much, the query gave us a data frame. And then to extract something from the data frame, we're just going to use integer position. So that was actually already a pandas command. So integer position, command iLook, square brackets to get 0. And now this is going to return a pandas series. All right, the next thing I want to do is extract just some of these pieces of data. To do that, I can extract data from a series using square brackets and a list. So this is that fancy slicing. So I've got double brackets here. The first set is extracting. The second set is creating a list. And the pieces that I want are the name of the tree and the priority. So let me go ahead and run that. There we go. We've reduced that series to just those two things. And then finally, the final answer was actually a list. This is a Python command, so it's going to be exactly the same as the first one up there. Just the list constructor, add the two parentheses, and away we go. There we go. I want to point out there's another way we could have approached this problem. So let me go ahead and start with the sorted priority list. So let's go ahead and put that right there. And sorted by priority. I could have extracted the columns first. And again, to extract data columns from a data frame, I'm going to use square brackets. I'm going to give it a list with the names of those. I'm just going to copy and paste the two columns that I want right from there. Okay, that's going to reduce this table to just tree and priority. And now from there, I could put in iLocation, grab row 0, and that's going to give me a pandas series with B and 100 in it. And I can turn that into a list. Okay, so I have options here. If you did it this way, that's great. If you did it that way, all I had to do was just reverse the order of whether I'm selecting by columns or by rows first. All right, let me go ahead, grab a timestamp, and we'll do problem 6. All right, another SQL question, guys. I like this one. This one's pretty straightforward too. Go ahead, pause the video, give this a try. Here's a little hint. Let's actually make this a little easier to read by putting the entire select on one line and the entire from on its own line. There we go. We can see there's only two things going on. There we go. Go ahead, give this a try, and then come back for the answer in 3, 2, 1, go. All right, so I'm going to start with trees right here. We're taking a look at the trees data table. And what we're doing is we're going to be selecting, and again, this is an aggregation. We're going to be using count. So it's going to go ahead and take this data and do some math on it. In this case, just counting. And that's going to relabel the new column as C1. And then we're going to do another aggregation, counting distinct species and labeling that column as C2. So let me go ahead. I've got two new columns, C1 and C2. Oops, C1 and C2. And then count species is going to be looking at just the species column right here. And all it does is it's going to go ahead and count how many entries there are. So there's 1, 2, 3, 4, 5. So that's going to get the number 5 right there. And then the second column is counting distinct species. So that's going to ignore any duplicates. So it's going to say M, we got 1. Ignore that, we already have an M. P, that's a second one, so 2. Ignore that one, we already have a P. Ignore that one, we already have an M. So we have 2 distinct species, just M and P. All right, this creates a new data frame. So this will be row 0 of the new data frame. And we'll slide those columns over. All right, let me go ahead and we'll comment my prediction, uncomment the code, and we'll go ahead and run this. And yep, check that out. 5 and 2, row 0, relabeled columns. All right, so to do this problem in Pandas, this is where I'd like to introduce, whoops, there we go. Mike, stop that. This is where I'd like to introduce the value counts function, the new material for today. This is a lot like the bucketize, and in fact, you could do this same problem, predict the output, the counting, with a In fact, this is the one that will require the bucketized version. Pandas provides a value counts that does pretty much the same thing. So let me go ahead and add a new cell, and we'll just demo this new feature right here. So if I create a pandas series right there, I'm going to be giving it a list to initialize it, and we'll just put in some characters. 1, 2, 3, 4, 5. We'll go with 6 characters. So we'll have the letter A, B, C, A, B, A. Something like that. Okay, there we go. So this will give me a pandas series, just like that. I'm going to go ahead and store this in a variable. So we'll store that in X. All right, and then we'll just print out X like that. Cool. Next thing we'll do is call x.valueCounts. Yeah, just like that. Okay, and what this does is it's going to create a brand new pandas series. It's going to give the index values the actual data from my original series. So that's the index, and the value of that series is going to be the number of occurrences of each of these pieces of data from the original series. So A appears 3 times, 1, 2, 3. B appears twice, there's 1, 2, and C only appears once, so I get 3, 2, 1. So, all right, I'm going to grab one more cell. This is what I'm trying to do. I'm going to be counting the number of species, counting the distinct species, and putting them in a new data frame. All right, so let me grab a new cell. I'm going to be doing this in a number of steps. So first, we're looking at the trees table. I'm going to be counting individual species. So this is going to be, let me go ahead and extract the species column, just like the species. So that'll be just like that. And now this is a pandas data frame series. So what I can do from there is just grab the length of this, and that's going to give me 5. That's going to go ahead and count up all of the essentially values in the list or series and return that. All right, now to get the number of distinct species, I'm going to do something similar. We'll start with trees. We'll be grabbing the species column just like that. And then this is a series. We'll be calling value counts on this. That's a method, so I need the parentheses and the dot. And that's going to give me a brand new series where the indices are the data from the original series, and the values are the number of occurrences. Now, I don't want this. What I want to know is how many rows there are, or how many data items are in here. So we'll be calling length on this and getting the number 2. Okay, now if we look back up here, the final answer was actually a data frame. So we'll be creating a brand new data frame. So pandas data frame. All right, well, this is a constructor, so I'm giving it parentheses. Now I have tons of options for how I create data frames. When I go back up here, I can see that this one has just a default indexed rows, but I have given the columns names. So I'm going to go ahead and use the list of dictionaries option. And there's only one row, so I only need one dictionary. But I could have made a dictionary of dictionaries, a list of lists, and then given it headers. Let's see, a dictionary of lists, or there's a fourth, list of lists. I think I said that one. There's a fourth option. I don't remember what I already said though. Okay, so this, the dictionary entry is going to have 2 columns. So it's going to have C1 and C2. All right, now these need to be dictionary entries. So they're key and value pairs. So let's see, the key here is C1, and the value is going to be this stuff right here, the number of entries in the column. So that's going to be 5 in the end, but it's that code that gets me there. Okay, for the C2 column, I'm going to need this code right here. All right, one final thing, the labels of the columns are strings, so I need to put those in quotation marks. Just like that. I think this, I got a good feeling about it. Let's go ahead and run it. There we go. Looks like it worked. All right, excellent. All right, guys, last one. Okay, go ahead, pause the video, give this a try, and then come back for my solution and explanation. All right, as I start this problem, first thing I'm going to do, I see I've got a SQL query. I'm going to go ahead and rearrange this a little bit. So I've got my select from and group by, and order by, all on their own line. All right, so something, I like that. That looks good to me. Okay, next thing I'm going to do, I'm just going to take a look at this. I'll be using table trees, so I'm going to start with that. We'll go ahead and bring that up so we can take a look at it while we work on this problem. I'm going to be creating a new data frame because pretty much all of these queries return data frames. It's going to have, looks like 3 columns, species, count, which is going to be this aggregate data, and then size, which is this aggregate data. And the other thing I want to just focus on right away, I've got a group by right here. So I'm going to be going through and grouping by all the different species. So my rows will be M and P. And then I'll be counting the species and averaging the size. So essentially when I have a group by, this is going to create 2 separate independent tables. It's going to do this analysis on it. Whoops. This analysis and that analysis on each individual table, and then compile the results in the final table. So you can think about it, this is happening in a number of steps. Okay, so as I go through this, let me think about it like this. So I'm going to be creating a new table with all of the M rows. And here's the last one like this. Oops, I missed. Let me bring that trees back up. We'll comment this so that it doesn't crash. Just a quick typo there, sorry about that. All right, then the other table we're getting is going to have the 2 P rows. So I'll get that one and that one. Oops, too much. I'm going too fast here. Okay, so I'll get those 2 things. Now, when I do this, what I'm going to be doing with each of these tables is counting. So this will be table species A. Whoops. M. What are you doing, Mike? And table species P. I'm going to count them. So the count is 1, 2, 3 rows. And I'm going to look at the average diameter. So I've got 8 plus 10 plus 12 is an average of, well, the total is 30. Divide by 3 is going to give me an average of 10. Here, this table has 2 rows, and 6 plus 8 is 14. Divided by 2 is an average of just 7. All right, there we go. So there's me showing all my work. This group by is going to give me 2 separate tables. And then I do my analysis per table. And at the end of the day, this is all getting turned into a brand new data frame. It's going to have column label species, count, and size. Species is going to be M, 3, 10, and P, 2, and 7. All right, and these all get new indices, so we'll have 0 and 1. All right, kind of like that. All right, I'm going to go ahead and comment all this workout, and my answer prediction will bring the query back, and we'll run this and see if I'm close. All right, only difference is that it did this average and turned it into a floating point number. I'm not surprised about that. We have to divide by the number of rows when we do this calculation, so this is looking good to me. All right, so this is going to wrap it up for me. I do have one more question here. This question is actually very challenging. I'm going to leave this out there. I'm not going to do it. I'm not going to ever put anything this challenging on an exam. You can do it with everything we've learned in this class. So I say go for it. Give it your best shot. Think about how you might do it. You've got the answer. You should be able to come up with something in Pandas that gives you this data frame right there. All right. So when you get it right, you'll know because it'll look exactly like that one. All right, next up, there's also a number of additional exercises here. These are all questions from the hydrants table. Again, this is just practice on your own. You'll know when you get the right, I mean, I don't even really feel like I need to provide answers, because you'll know when you get the right answer because you can delete the comment and run it. And just a note, Mina and I took very different approaches to this lecture. She's using the PDF version of the worksheet. She's writing it out by hand, going through with her cool tablet. I don't have one of those. I'm just doing this in Jupyter Notebook, doing my best shot, and you guys do not want to see my handwriting. I've got a bit of a tremor, and it's nasty. My evaluations in past years have said never handwrite anything again, so I'm doing my best. She also went ahead and broke this into 3 pieces, and she did all of the additional exercises in one of hers. So if you do want to see a walkthrough of these, if you're looking for even more, go for it. Go ahead and check all these out. And in her lecture, she also only did, I believe, part A of all the questions. She didn't do any of the part B's, the extra conversion. So again, we took very different approaches. If you want to go check out her videos, I do recommend it. I think she's got a great style, and it really adds a lot to the class. Yeah, I think I'm going to wrap this up here. Okay, if you guys have any, oh, I also forgot. Go ahead and close your connection when you're done. Yeah, if you guys have any comments on this video, or if you enjoyed it, would like to see something different in the future, go ahead, put a comment in the YouTube comment box, or you can use our feedback form online if you want to remain anonymous. All right, have a great day, everybody. See you on Wednesday.